So let's go through an example with angle, angle, side. Now here it's kind of listed in order like that. However, part of our work here was that we'll sometimes need to draw these triangles, and we'll try to make them to scale, but it can be really tricky. So just do the best you can with it. You'll even see mine are not going to be perfect when I'm drawing them, but I try to get roughly these angle measurements when setting it up. So typically what I do is I start with a flat side, and you can always adjust this. These are good to do with a pencil, but like it telling me that alpha is 36 degrees, and what I just kind of visualize is like, okay, here's 90, here's 45, so 36 is a little bit less. I don't know how far that goes, so I'm just gonna guess here, something like that. And then beta is 24 degrees, so that would be this one here. Maybe that works. It could even be a bit less maybe, but close enough. We have an acute angle and acute angle. I'm happy with that. All right, so alpha is 36 degrees, so I'm going to call this 36. And beta is 24. And then we have a side length of 4, which just make note of, here's beta, here's B, so those should be opposite of each other. So where I drew 24 degrees, opposite of that will be 4. So this is where we see angle, angle, side. Notice that it could also be read as side, angle, angle, same exact thing. The key is that those are opposite of each other, and then we have one more angle off to the side there. We could have drawn it over here. That would have been fine too. So in terms of solving, what I need to find is we have a missing side length A, we have a missing angle measurement of gamma, and we have a missing side length of C. So I need to fill in those pieces there. Now I'm going to start with the angle measurement. Like I said before, is I just kind of immediately jump inside and see we have 36 and 24, which means we can fill in the blank there by just taking gamma should be equal to 180 degrees minus 36 minus 24. So gamma is going to be 120 degrees. So we filled in that piece there. All right, then to solve for my side lengths, I'm going to need to use law of sines. So I'm going to do is look for a pairing that I know, and it's going to be that I know beta and B. So that means I can create the pair sine of 24 degrees divided by 4. So I know that ratio is what's going to be working for our triangle. And then let's go with A. So I'm going to do sine of 36 degrees, so using alpha, and then divided by our unknown of A. And then we just solve for A, so I'm going to cross multiply, and then divide. So A is going to be equal to 4 times sine of 36 degrees over sine of 24 degrees. Again, just make sure your calculator is in degree mode here, and that should give us a side length of 5.78. So for A, we have 5.78. Now, again, just to emphasize, you cannot use the Pythagorean theorem here. Do not. Instead, because this is an oblique triangle, what we need to do is use law of sines again. So I'm going to do is use that same ratio, that sine of 24 degrees over 4 is equal to, and now I'm going to use gamma with C, so it's sine of 120 degrees over C. And then we're going to do cross multiplication, and then divide. And notice with this, I could make an exact substitution in that from the unit circle, we could grab an exact value for sine of 120 degrees. However, since we don't have an exact value for sine of 24 degrees, I'm not going to worry too much about. If you could make an exact substitution everywhere, that's awesome. But if I'm going to have to use the calculator for this, then I'm just going to use the calculator for everything. So we would type all of that into the calculator, and that should get an 8.52. So this side length here is an 8.52. And then I just run my little mental check of, let's see, like the smallest angle is across from the smallest side length. The largest angles across from the largest side length. As you can see, as best as I try to sketch this, like this is not 120 degrees here. But I used the information I had, I just had to draw it a little differently. But without knowing that side length was actually really long there, then it was kind of hard to guess that that would happen. So that's law of sines with angle, angle, side. So with this case, you'll always have two angle measurements. So you can find the third using this rule with 180 degrees. And then it's just a matter of applying the law of sines twice using different pairings. But you should have one where you have all the information filled in. Also, one more note of like after you find 5.78, we technically could have used sine of 36 degrees over 5.78 as kind of our known ratio. I don't like to do that personally because this value is rounded. So by using a rounded value as part of this calculation, it can introduce more error and it might give an answer that's slightly off. So I typically like to go with the exact values that are kind of originally showing up on the triangle and just sticking with those as long as possible and avoiding like kind of recycling any rounded values, because this is correct as an answer, but in terms of calculations, there might be a bit too much error there.